Today's webinar topic is calibration system for all prices, noise, vibration, and shock by Mr. Raghu, myself. So today we'll be focusing on products from Spectra. They are manufacturers of calibration system, from Grass, who are manufacturers of microphone, and from two other principal, Metra and Norsamic. So we'll get started with the company introduction, and then we will go enter into today's webinar. Okay, Adams. So what we do and what is Adams? So Adams is acoustics, dynamics, and model system. We are present in the field of noise and vibration. So we are able to cater to all the requirements from starting from sensors to data acquisition system to vibration shaker. Okay, so we are a 25-year-old company, and we are able to cater to all the requirements in the field of noise and vibration, from vibration sensors, acoustic sensors, and any requirement on durability testing. So empowering technology. So this picture actually shows that we are present in all the fields where noise and vibration has now become a basic measurement or essential part of any field, be it aerospace, defense, rail and transportation, or automotive sector. And also the latest testing needs of the automotive segment, that is e-vehicles. So total testing solutions for NVH and durability testing. So starting from sensor data acquisition system, we are able to offer you a complete package end-to-end solution. So that's what makes us stand apart from other in market. We have the facilities in the picture in Chennai, headquarters, the calibration system from Spectra. We have an accelerometer calibration system from Spectra. This calibration shaker for durability testing, 3.5 ton shaker from LDF, and we also have another shaker for durability testing. So I am now ending the company introduction. From now on, Mr. Raghu will take over for today's presentation. So, yeah.
Yeah, good morning. This is Raghu here. So once again, I welcome you all for today's webinar. So Adams is offering a complete calibration solutions for the acoustics and vibration and shock. So from different principles such as Spectra, Germany, and MMF Germany, and Grass, Denmark, and Norsonic, Norway. Yeah, so before getting into the subject, so I just want to give you a small information about what is calibration and why calibration is so important. So calibration is a process of comparing an unknown value of DUT with a known value of a reference standard. So why the calibration is so important? For taking the precise measurement with a well-known measurement uncertainty and the measurement results which are measurable by the same standard, and for guaranteeing the legal security as the measurement results taken can be traced to the respective national standards. For obtaining an accurate and precise measurement results, the instrument must be traced to the national standards, and the traceability needs to be ensured and maintained by the calibration hierarchy. So which is traceability. So it should be traceable to the national standards such as NMI. So for the German, it's a PTB, and for India, it's a NPL. So, and the reference standards, it's a DAX. It's a German accreditation body. So it's a laboratory accredited by DX. It's a reference standard. So in India, it's a NABL, National Accreditation Board for Testing and Calibration Labs, and the working standards. So it is non-accredited in-company laboratory. It's an example, the car manufacturers. So they can do their calibration according to the working standards. And the last is measuring and testing equipment calibrations, such as shock sensors in crash-touching laboratory. So all the instruments need to be traced to the any one of the national standards. So for everyone who wants to take an instrument, they should calibrate their measuring instruments in a regular interval by accreditation calibration laboratory, and they want to perform the calibration in routine by using the traced calibration systems. The calibration certificate, which provides you the deviation of the instrument with reference to the master instruments and which is traceable. So Spectra. So Spectra, it was founded in the year of 1994. It is located in Dresden, Germany, and they were expertise in the field of dynamic measurement of mechanical quantities. And Spectra has grown over the year as a strong company in the field of sound and vibration engineering. And the Spectra offering a product such as calibration solutions, device testing, and structural testing, and engineering solutions. The calibration solutions. So Spectra is offering a both primary and secondary calibration. So the primary calibration. So it's an absolute calibration method for the vibration and shock. The excitation axis is traced back to the wavelength of helium neon laser light by laser interferometry method. So for the reference standard accelerometer calibration, and it's a secondary calibration, it's a comparison calibration method. The calibration by comparing the test object with the reference standards, so such as the unknown transfer coefficient of a test object is traced to the known transfer coefficient of a reference standards. Portfolio calibration capabilities. Spectra is offering a different calibration solutions such as acceleration, shock, and so acceleration calibration system. What are the sensors can be calibrated? It's a vibration sensors such as ICP, charge, voltage, and MEMS type and piezoresistive sensors, and low frequency sensors such as seismic and vibration meters and vibration calibration. For the acoustics, what are the microphones can calibrated, or the such as measurement microphones and sound level meters, and piston phone and acoustic calibrator and artificial magnetoids. For the electrical capability, it's a comparison calibration method for the charge and voltage amplifiers, and for the dynamic sensor calibration, such as angular rate sensors and pressure sensors and pulse force hammers and force transducers. And the Spectra is offering a complete turnkey solution, such as a one-stop concept for the entire system. So Spectra is offering an exciter for the mechanical and acoustic applications. So for the vibration exciter and shock exciter and the free field chamber and pressure field chambers. And the SRS-35, it's a vibration control unit. It's the heart of the CS18 and the calibration software. So where you can program for the calibrations. So first we'll start up with the accelerometer calibration. So it's a according to the ISO standards 16063, it's a method for the calibration of vibration and shock transducers. So Spectra is offering both primary and secondary calibration. So primary calibration such as CS18P VLF, it's a very low frequency from the frequency range of 0.05 Hertz to 160 Hertz. And the CS18P HF, it's a high frequency primary calibration system from the frequency range 5 Hertz to 20 kilohertz. And CS18P seismic for the frequency range 0.1 Hertz to 400 Hertz. And for the secondary calibration system, so Spectra is offering a CS18 VLF, that is for very low frequency from a frequency range 0.05 Hertz to 160 Hertz. And CS18MF, that's a medium frequency calibration system from 3 Hz to 10 kilohertz. And CS18HF, that's a secondary calibration system, high frequency, such as 5 Hz to 20 kilohertz. And the CS18HA, that's a high acceleration. So from the frequency range 65 Hz to 500 Hz. And CV10, that is the mobile calibration system. So for on-field applications, so the frequency range 5 Hz to 10 kilohertz. So the system CS18 with the vibration control unit, that controller, and CS18MF and CS18HF and CS18 primary HF and CS18 primary very low frequency system and CS18P, that's a primary for the seismic, and CS18H acceleration for the amplitude linearity measurement of sensors, and CV10, that's for the mobile calibration system. So CS18 VLF, that's a very low frequency. So it's a secondary calibration according to the ISO standards 16063. So the calibration is basically by the comparison method. So what are the types of sensors they can calibrate? Charge type, an ICP, and voltage, and DC, and piezoresistive sensors. And it is excited by a sinusoidal input. And apart from the sensors, you can do the calibration of vibration meters and vibration calibrators from the frequency range of 0.2 Hz to 160 Hz. And the maximum DUT mass can up to 900 grams. And the resonant frequency surge from 10 to 200 Hz, you can do it. And CS18MF. So only the differences between the frequency ranges and the excitation. So that's the very low frequency shaker. Here it is the medium electrodynamic shaker. So this is also a secondary calibration according to the ISO standards. So 16063, and you can do the calibration by the comparison method. And the types of sensors it supports, same as the low frequency systems. And apart from the sensor calibration, you can do the vibration meters and calibrators from the frequency range 3 Hz to 10 kilohertz. CS18 high frequency calibration. So this is also traceable to the secondary calibration according to the ISO standard 16063, and the same sensors you can do it. Only the difference is the frequency range 5 to 20 kilohertz you can able to perform. And HA. So it is specially designed for the certification and calibration of amplitude linearity for the sensors at certain frequencies with high accelerations. So it's a secondary calibration for the amplitude linearity according to the ISO standards 16063 by comparison method. And it supports charge type, ICP, voltage, and variable capacitance and piezoresistive sensors. So CS18P, it's a primary calibration system for the high frequency. So according to the ISO standards 16063, and here you can calibrate the reference standard transducers and primary calibration of laser vibrometers and reference laser vibrometers according to the ISO 1606341 from the frequency range 5 Hz to 20 kilohertz. And CS18P, it's a primary calibration system for very low frequencies according to the standards ISO 16063. And the types of sensors you can do vibration sensors, calibrators, and laser vibrometers, and the reference standards. From the frequency range 0.05 Hz to 160 Hz. And CS18P seismic. So this is specially designed for the seismometer calibration and low frequency sensors calibration, and sensors for measuring the vibration emission, so such as the vibration meters. So DIN 45669, it's a German institute for the standardization with the sinusoidal excitations. And you can do the primary calibration of reference standard accelerometers and the calibration of sensors, vibration meters, and vibration calibrators. CV10 mobile calibrator. So this is specially designed for the on-field calibration for the vibration transducers And it's a one-stop solution for on-site calibration from the frequency range 5 hertz to 10 kilohertz. And the maximum acceleration you can go up to 20 G peak, and you can vary the acceleration and frequency during the measurements. I just want to show you some functionality and features of CV10. So, CV01, it's a handle calibrator. This is specially designed for on-field verification of your measuring sensors. So before going for the measurement, you can make sure your sensor is working properly by exciting the known frequencies such as 159.16 Hertz and 1 GRMS. And now acoustic calibration systems. So which is according to the IEC standards, is an International Electrotechnical Commission 61094. The method for the calibration of working standard microphones, and IEC 61672. It's the method for the calibration of sound level meters, and IEC 60942. It's a method for the calibration of sound calibrators. And IEC 61043, it's the method for the calibration of sound intensity microphones. And IEC 61252, it's a method for the calibration of noise dosimeters. And Spectra is offering acoustic calibration for both primary and secondary calibrations. So CS19P, it's a new one for the pressure field microphones. So from 31.5 Hertz to 20 kilohertz. And for the secondary calibration, Spectra is offering a CS18FF, that's a free field calibration from 125 Hertz to 20 kilohertz. And CS18SPL, that's for the pressure field microphones from 31.5 Hertz to 5 kilohertz. And CS18SPL and very low frequency. For the pressure field microphones, very low frequency, 0.1 Hertz to 31.5 Hertz. And CS18SPLE, that's for the noise dosimeter, it's 63 Hertz to 8 kilohertz. And CS18 audiometry calibration, that's 125 Hertz to 8 kilohertz. How the system looks. So the first one, CS18FF, which has the anechoic chamber. So that is 2 meter by 2 meter into 2.5 meter. And the pressure field with the acoustic coupler, that's for the pressure field calibration. And SCS18 SPL VLF, that is with the infrasonic calibration for the very low frequency applications. And the next one is CS18 for the audiometry calibration, and the CS19 primary CS18FF, that's the free field calibration. It's a secondary calibration according to the standards of IEC 61094 for the working standard microphones and IEC 61672 for the sound level meters. And this is working based on the substitution method where the master microphones will be calibrated initially and the DUT will be placed after that. And based on the substitution, the sensitivity will be calculated for the frequency range 125 Hz to 20 kilohertz, and the maximum sound pressure you can go up to 124 dB. And for the pressure field microphone calibration, so according to the standards IEC 61094 for the working standard microphone, and for the pressure standard sound level meters, so IEC 61672. So it's a comparison method. It's a back-to-back calibration. So frequency range from 31.5 Hz to 16 kilohertz with the sound pressure ranges up to 124 dB you can able to perform for the pressure field microphones. And CS18 SPL for the pressure field microphones and very low frequency. So it's based on the infrasonic calibration. So this method is specially developed for the calibration of general types of measurement microphones between 0.1 Hz to 31 Hz. And it includes the design of active comparison coupler and experimental low frequency reference microphones and new methods for the frequency response calibration. So one method is applies an electrostatic actuator, which requires a low pressure measurement tank, and other requires a related to the reference microphone, which needs to be calibrated. And for the secondary calibration of measuring microphones by comparison method from 0.1 Hz to 31.5 Hz, and the maximum dB you can go up to 124 dB. And audiometry calibration. So this is for the simulator of human heads and ear. So it's a IEC standard 60318 for the measurement of force and acceleration transmission property by mechanical impedance method. The frequency range up to 8 kilohertz you can go for it, and the maximum force is 5.4 Newton at the contact force. Either it's a 5.4 and 2.5 Newton, and the excited velocity is 1 mm per second peak for the calibration of artificial mass heads. And CS18 SPLE, this is specially for the electrical calibration of noise dosimeters according to the standards IEC 61252. It's a comparison method. The maximum you can go up to 8 kilohertz and the sound pressure range up to 124 dB. This is for the noise dosimeter pressure calibration. CS19 SPL, it's a primary calibration method. So the principle is based on reciprocity. So this is specially developed for the high fidelity measurement microphones by using the pressure reciprocity calibration method. So during the calibration, we have to use two microphones are connected at each end in a closed cylindrical cavity. So how the calibration will be performed? So it is important to understand the acoustic field inside such a cavity, include the all thermoviscous acoustic effects. For high frequency, it's an acoustic boundary layer. For low frequency, it is related to the isothermal behavior. So based on the acoustic transfer impedance, the sensitivity will be measured. So for the frequency range 31.5 Hz to 20 kilohertz, and the measurement uncertainty, it's like 0.17 dB. This is for the dynamic sensor calibration. So Spectra is offering a DRE. It's a dynamic rotational exciter 01. So I just want to show you some functionality and feature of that video of DRE. So this system is specially developed for the dynamic angular rate measurement sensors for the calibrations and the function and features. So CS18 for the gyro sensors calibrations, it's a secondary calibration of rotation rate sensors, and it's especially developed for the device testing and characterizations from the frequency range 1 Hz to 5 kilohertz, and the maximum angular velocity can go up to 5000 degrees per second, and the maximum angle you can go up to 30-degree peak to peak. The maximum payload, that's the sensor mass, so up to 100 grams. And shock calibration system. This is based on the standards ISO 16063, the method for the calibration of shock transducers. So Spectra is offering a primary and secondary calibration. So primary calibration, it's a CS18P medium shock. The maximum acceleration you can go up to 5000 G. And CS18P HS, that's a high shock. Maximum acceleration you can go up to 75,000 G. And the secondary calibration systems. So it's a CS18LS, that's a low shock. So maximum you can go up to 200 G from 10 G. And CS18MS, that's a medium shock. Maximum you can go up to 4000 G. And CS18LMS, that's a low medium shock. The maximum you can go up to 15,000 G. And CS18HS and VHS, maximum you can go up to 2 lakh G. So the CS18LMS and CS18LS, CS18VHS, this is how the system looks. So why do we need a shock exciter? That is for the calibration of shock accelerometers and environmental testing, such as structural testing and MEMS characterizations. So how we can separate the exciters? So based on the working principle and the acceleration range and impulse duration. So Spectra is offering a low shock system, which is working based on the simple pendulum method and LMS. So that's a pneumatic low medium shock. So pneumatic method for the calibration, and HOP, that's a Hopkinson method for the medium shock, and HOP for the high shock, and VHS, that's a very high shock. So these are the principles behind the shock calibrations. So you can see the left side picture. So you'll have some idea with the simple pendulum method. The maximum can go to 2000 G. For the pneumatic method, we can go up to 5000 G. So beyond that, we have to choose the Hopkinson method, which is patented to the Spectra. CS18LMS, that's a low medium shock calibration system. It's a secondary calibration for the shock sensors according to the ISO standards 16063 by comparison method, and the secondary calibration of accelerometer standards. The maximum you can go up to 10,000 G, and the type of excitation is a shock Hasen, and the pulse duration is up to 5 milliseconds. Now, how it is working? It's based on the hammer anvil method to generate the shocks. So it's a pneumatic driven pulse generator. So pneumatic driven shock exciter, which provides you the wide amplitude range. So within a barrel, so a projectile is accelerated by pressurized air used by the hammer, and the air pressure is kept constantly. The kinetic energy of a projectile, which can be controlled by the motor driven mechanical stop that allows a precise adjustment of a projectile starting position to the distance which getting accelerated. So this is a projectile which hits the anvil area. So anvil, it's a metal working plate, so which has the high inertia, which can transfer the energy from the hammer to anvil for where you can mount the back-to-back sensors and DUT with a allowable tolerance. And CS18LS, that's a low shock calibration system for the shock sensors according to the ISO standards by comparison method. And in this method, so you will be having a hammer and anvil. So hammer pendulum and anvil pendulum. In anvil pendulum, you will mount the reference standard accelerometer and DUT. So the maximum shock range you can go to 200 G, and type of excitation is half sine. and the maximum pulse duration is 10 millisecond. This is how the hammer anvil principle will works to generate the shocks. So the hammer which hits the anvil pendulum and to generate the shocks. CS18 VHS, it's a secondary calibration of shock transducers. It's a very high shock system according to the standards ISO 16063 by calibration method. And the maximum amplitude you can go up to 1 lakh G, and its excitation is a sinusoidal shock. And the pulse width, half sine and full sine, it's 50 microseconds working principle. So it's a Hopkinson bar principle, which is patent to spectra. So the principle, it's a propagation and reflection of a mechanical waves in a splendid bar, which generates the shock. So which is excited by the piezoelectric actuator, that's a shock exciter. So how it is working? So to determine the testing and calibrating acceleration sensors, so within a barrel, a projectile is accelerated pneumatically hitting the end of the bar. It is adjustable distance by exciting the strain pulse within the bar. The pneumatic control allows to retract the projectile after each shot by applying a negative pressure and to generate a shock. So you can see the DUT is mounted over here, and this will be excited, and which gives the movement, the reflection of the Hopkinson bar, and which excites the strain gauges, and it will measure the shocks, and the DUT will be getting calibrated. CS18MS, it's a medium shock calibration system. It's a secondary calibration system according to the standards ISO 16063. It's a comparison method. So for the calibration of shock accelerometers, the maximum range you can go up to 4000 G, and the type of excitation you can either give a sine shock or burst. The maximum pulse width you can go up to 40 microseconds for the medium shock calibrations. So the same Hopkinson method. So you'll be giving a driving voltage to the exciter. The exciter, the piezo exciter, which stacks, and it will give the, due to the reaction mass, it will give the reaction force according to the Newton's second law. The same force will be applied to the Hopkinson area, that Hopkinson bar. So both Hopkinson bar and both are mounted on the same aluminum bar. So the propagation and reflection of waves, so that generate the shocks, and you can able to measure the shocks for the calibrations. And CS18P-HS, it's a primary system for the calibration of shock sensors according to the ISO standards 16063, and the maximum you can go up to 1,50,000 G, and it's based on the sine excitation for the reference standard accelerometers. The same principle as the Hopkinson method. And CS18P-MS, it's a primary calibration system for the medium shock according to the ISO standards 16063. It's a primary calibration of reference standard shock accelerometers. Maximum you can go up to 5000 G, and type of excitation you can give sine or burst sine, and the pulse width is up to 40 microseconds. And this is also a same concept where you will be giving the driving voltage to the piezoelectric actuators. So that actuator stacks, and which due to the reaction force which moves the which creates the reaction force, and that will be applied to the Hopkinson bar. Due to the reflections, you will be able to get the shock exciters. And the SRS35. So it's a vibration control unit which has the integrated signal conditioner, and it's a modern system concept. And the one controller, we can use it for different applications such as acoustics and shock and vibrations. So it is it has the module called CAL QICP, that is for the electrical calibration of signal conditioners. and which has the analog input module. So where you can connect your microphones and accelerometers. It has the inbuilt signal conditioners, and it is having two output for monitoring the signals from the sensors. And it has the CPU, inbuilt CPU. So that will give the output voltage to the exciters for the different applications such as acoustics and vibration and shock. And it has the communication for both, either you can connect through the Ethernet or you can connect through the RS-232. And it also has the piezoresistive module for calibrating the piezoresistive sensors. And it has the optional power supply modules, that is for giving the excitation power supply for the DC sensors. And for the primary calibration, for the laser input, it has the different module. So that's optional. That's along with the primary calibration systems. So it is traceable to National Institute of Standards and Technology and PTB German standards, and tested in ISO 17025 accredited calibration laboratories. And the software, it's a CS18, it's a calibration software. So every hardware, every good hardware needs to be complemented by the software. So with the high performance, so it should be easy to operate, and it has the integrated sensor database, and you can export the data to Word or Excel, and it has the interface, automation interface, and they'll be giving optionally for the calibration database server, and optionally for the foreign database to interface with the system, and the calibration of digital sensors also can able to do it. Your benefits by using the Spectra system. So it's a high quality standards. So traced to ISO 9001 and DX and ISO 17025. And we have a wide range of products to support with different applications. And Spectra is offering a flexible, customized solution which suits for your special application needs and the range of use. So where we can use our calibration system, it's especially for the sensor manufacturers and quality assurance in the industry and certified calibration laboratories and national metrology laboratories and department for the supervision of measuring instruments such as automotive and space and military and aviation industries. So the customer worldwide references. So we'll be giving for different area, so such as automotive and aerospace and sensor manufacturers and calibration laboratories. And user reference list in India. So it's NPL, National Physical Laboratory in Delhi, and Ashok Leyland, it's in Chennai, and Fluid Control Research Institute, Palakkad, and Wipro Limited, Bangalore, and MSIL Rohtak, and Turbo Energy Chennai, and GIRC Chennai, and IIT Roorkee. So I will. So that's it. I will end up with the session. So I will. The further slides will be continued by my colleague. So I will transfer this slides to. She will continue further.
Okay, thank you, Raghu. Thank you for the excellent session. So I think many of the customers would now know the product range of Spectra. So Spectra has handle calibrators and a complete calibration system. So so now let us get back to calibration systems and products from principles. So Graf Sound and Vibration from Denmark. So Graf, they are manufacturers of microphones and a lot of other associated equipments for the acoustic measurements. So they are also a 25-year-old company. So today's focus will be on calibration products, calibration solutions from Graf. So let me start with small handheld calibrators. So Graz has both piston phones and calibrators. The most latest and innovative product currently as in market for the calibrators, handheld calibrators or sound calibrators from Graz. The special feature about this calibrator is with this you can achieve 4 levels in combination. So you can do 1000 Hz 114 dB and 94 dB and 250 Hz 114 dB and 94 dB. So you can also get to see the temperature, ambient pressure and humidity. So if you see, these are the screen displays of the acoustic calibrator. So the 4 levels, and you can also see the atmospheric pressure, temperature, and humidity. So I have a small video. Okay, so in this video, we now saw the 146A, that is the rugged microphone calibration of 146A. So again, coming back to products from Graz. So piston phones. So we have three different kind of piston phones. We have one type of piston phone, and we also have a class 0 type that is a laboratory standard for piston phone. The 42 AC piston phone is a high pressure piston phone. So 134 dB and 250 Hertz. So if you're having microphones that are having a measuring range up to 180 dB, it is recommended that you because you'll be able to calibrate your microphone at a higher 42AA is the standard microphone, 214 dB. So this is the common specification that is available in market. So if your microphones are the standard general purpose range is 120 dB or 140 dB, you can go for the 42AA. If it's more than that, it is recommended that you go AC. Next is the intelligent piston phone from Graz, the 42AB. It also has a PC interface. So this is again the 250 Hz 114 dB, but it is a class 0 type piston phone. This has high precision and accuracy. All the calibrators from Graz has a high precision and accuracy. So this has the most best accuracy. So it is a laboratory standard. So Graz gives you accessories that can be used along with the piston phones. So here we have a dual port calibrator that can be used along with the 42AB, where you can use a master reference microphone or a microphone that is calibrated and kept and can be used as a master microphone microphone for a level check using the 42AP. So you can introduce your DUT or the microphone that you will be going to use for your measurements. And then we have something called the octopus coupler. So this octopus coupler can be connected with the piston phone, and you can check 8 half-inch microphones at the same time using the 42AP. So if you're going to do a multi-channel data acquisition for acoustic data acquisition system or measurement, like you're going to use more than 4 channel or up to 8 channel, and you can use this octopus coupler. For a good acoustic measurement, it is always recommended that you start your measurement, do a level check, do a functional microphone which you're using. So this helps you to save a lot of time. Instead of going one by one, you can calibrate 8, you can do the functionality test, you can calibrate up to 8 microphones at the same point of time. So piston phone and calibrators. So what is basically the difference between two? Almost both of them are similar, but piston phone is highly accurate and more precise compared to the sound calibrator. So it includes a calibrated barometer for correction for local changes in atmospheric pressure. So the primary application for piston phone, where it is be used. So laboratories that has consider to go for piston phone and use piston phone for calibration. It can also be used for a single frequency level check. So in any field application, piston phones can still be used. It is not that you need not buy piston phone. So it is just that it is much more accurate than a sound calibrator. So the sound calibrators. So a sound calibrator videos to verify the microphone or to ensure the working functionality of the microphone that you're going to use for the measurement. So the accuracy is 0.2 dB. As mentioned here, the working principle of sound calibrator. So it has a small speaker, reference microphone, and an electronic circuit board. This reference microphone is again highly accurate, and it is also compensated for atmospheric. How it works, how the piston phone works is it has a reciprocating pistons actuated by precision machined cam disc with a sinusoidal profile. So both the piston phones and sound calibrators can be used for checking your microphones. So calibration we have from GRASS, we have the calibrator, we have the phase calibrator, and we have the intensity calibrator. Today, my focus will be on the calibration equipment, that is the microphone calibration system from GRASS. So in case you want to know more about these products, you can please write an email to info@advanced.com. So we'll be able to send you a product and give more information about the products. So let us now get into the microphone calibration system from GRASS. So the 90CA, the microphone calibration system. So I'm going to explain in a very, very simple manner, just step by step, what are the components and how a calibration procedure is done using the 90CA. So the two steps, one is level calibration. So as we have seen in the previous slides, we can use the piston phone AP or 42 AC for a level calibration. So we will be calibrating at 250 Hz 114 dB. We'll be getting the sensitivity of the microphone which you're going to use, say a 50 millivolts per Pascal. So the first process is level calibration. So that will be finished and you will get the sensitivity. The next step is frequency calibration. So the frequency calibration is achieved by using an electrostatic actuator. So the frequency calibration is performed in the frequency range of 20 Hz to 20 kilohertz. For low frequency calibration, 0.01 Hz to 250 Hz, you will have to use the low frequency actuator from GRASS. So you will be using this start from much lower frequency up to 250 Hz. So, so at the end of calibration, so it also has GRASS also provides you a PC interface and a software. So at the end of calibration, you get a beautiful report like this. So with a table, frequency response deviation and a graph. components in the calibration system. For level calibration, so you have a piston phone, so you have a preamplifier and a piston phone stand. You will introduce the microphone capsule and you will do a level check, 250 Hz, 114 dB. Next is frequency calibration from 250 Hz to 20 kilohertz. So you have the electrostatic actuator, you have the frequency calibration, frequency response calibration stand. So you will be mounting the microphone and doing a frequency response calibration. So to start with, we have a PC interface and software from GRASS. Next is signal conditioning. So the low frequency calibrator or electrostatic actuator requires a power module. In case you're going to use a LEMO, externally polarized microphone for calibration, you will be needing a LEMO power supply and a lot of other signal conditioning units. So this is the second part. So level calibration. So we have seen it. You will be using a piston phone to get sensitivity. And the next stage is frequency calibration. So this is it with respect to GRASS calibration system. So it is again easy to use. So you can have it in case you're having like more microphones or something. So you can have an accredited calibration in your own facility. Many OEMs who have been using more than 10 microphones or sensors can surely consider to buy and equip your with this GRASS calibration system. Acoustic calibration needs. So whatever your needs is, be it a field level check, or if you're acoustic sensor user, you have from just one sensor or two sensor or less than 5 microphones, you can consider to at least basically have an acoustic calibrator or even the piston phone. So if your lab or you're using more than 10 or 25 microphones, you can consider to buy and equip your laboratory with a GRASS calibration system. That is a completely automated system. So you can calibrate in an instant and print your own certificate. So GRASS product range. So they innovating acoustic sensor. So GRASS tries to improve their product and make an innovative product. So like that makes them stand up in the market. So the most recent launch is UTP microphones, that is 1 mm thick surface microphones, and the rugged microphones, the 46AE, which we saw the calibration of the 146AE. The 146AE, and there are a lot of other associated microphones. So these are called a rugged microphone or engaged microphone from GRASS. But this can be still used in case you will be using microphone with less care. So in case you tend to drop it down, then you can consider to use the rugged microphones from GRASS. They are also manufacturers of all other equipments, but I just want to mention about the UTP and the rugged microphones from GRASS. Next is we will be seeing the vibration calibrators and the vibration calibration system from Metra. So Metra is a 60-year-old company. So they are manufacturers of sensors, signal conditioners, vibration meters, and tabletop calibrators, CPAT accelerometers, and many more. So vibration calibrator. So we have been seeing the CV-01 from Spectra, that is a single frequency 160 Hz 1G, and we have also seen the CV10 from Spectra. So and we'll be now seeing a range of calibrators from Metra. What makes them unique, and you always have to need something different from others. So what makes them unique? So we'll see them in the coming slides. So this is the vibration calibration system from Spectra. So it is small, portable, and it is like a tabletop. You can put it on the tabletop and do the calibration. So this small system allows you to calibrate your sensor completely, but from the frequency 70 Hz to 10 kilohertz, and the amplitude is 1 meter per second square RMS. So at the rear end of the calibrator, you have a BNC connector. You can mount the sensor over here. The another advantage of using Metra is you can use sensors that are as heavier as 400 grams for to be mounted on the calibration system. So the sensor will be connected at the rear end of the VC120 system, and it displays the sensitivity. So this contains all the signal conditioning charge and IEP. So it is a beautiful small tabletop that allows you to calibrate your sensor in the complete frequency range of 70 hertz to 10 kilohertz. So it is also complemented by software. So at the end of calibration, you also get a beautiful report from Metra. So the other range of calibrators that are available from Metra, so VC20 and VC21, this is a small tabletop calibrator. This is a single frequency, single G level. With VC21, you can do multiple frequencies and multiple amplitude. VC21D, so this is more similar to VC21, but in VC21D, it allows you to calibrate eddy current probes and for non-contact type displacement sensors. So Norsonic, they are manufacturers of sound level meters and building acoustic excitation equipment. So they are having 50 years of technical expertise in the field of acoustics, so innovative sound instrumentation. So these are the product range: sound level meters, sound analyzers, building acoustic equipment, vibration meters, and acoustic camera. So acoustic camera is one of the most interesting product from Norsonic, and that is the most happening and interesting product in the market as well. So see what you hear. That is what acoustic camera about is. So we do have a webinar on noise source localization, and we'll be focusing on the acoustic camera from Norsonic and a lot of other noise source localization solutions from Adams. So again, we'll get back to today's topic, calibration system. So we have a calibration system from Norsonic. So this allows you to perform acoustical and electrical calibration of sound level meters, microphones, sound calibrators, and any measuring equipment, any related sound measuring equipment. So this is the complete system in itself. So this has a PC and a software. So it has a barometer, hygrometer. So it also has a DC power supply. It has a small chamber for the microphone calibration, and for the level calibration, it has the piston phone here. We have the computer with the software. So we have the voltmeter here. So this is the sound isolating measurement chamber with reference microphone. So we have the thermometer, hygrometer, and tensiometer and sound calibrator. So Norsonic product range, they are manufacturers of sound level meters, vibration meter, acoustic camera, and building acoustic excitation equipments. So partial reference list, as already my colleague Raghu has shared, I would like to share a few more reference lists for the tabletop handle calibrators from Metra and calibrators from GRAS. So so like various institutions and labs based on their requirements, so they go for piston phones. So they also, the CSIR labs, they also have piston phones. So ISR, they are having low frequency calibrators. They also have piston phones. Automotive customers, so many of them have piston phones as well as acoustic calibrator. So one of them has a complete calibration system, and they calibrate all their sensors by themselves. So it is really good thing if you have a complete calibration system. Okay, so coming back to the topic, today's topic. So calibration system for all prices. So like if you would have attended our previous webinar, Managing Director Ganesh sir would have informed you about the starting prices of the calibration system we have. So we have system ranging from 1 crore rupees for the vibration calibration system, that is the C18 system, and then the C01, that is the smallest system from Spectra, handle calibrator that comes around 1.75 lakhs. The shock calibration system, so you have very high shock, medium shock, high shock, and low shock. So these seems to be more expensive than the vibration calibration system. So you have something from 2.93 crores to 1.73 crores. And the acoustic part, so we have the Spectra here. We also have the Norsonic. We also have the GRAS somewhere in between. And we end with GRAS acoustic calibrator. So that ends at 1.6 lakhs. Access options are also available for you to customize the solution as per requirement. So whatever be your requirement, if you are a sensor user from like you have one sensor vibration accelerometer at least, it is recommended that you have a CV-01 in your lab or as part of your equipment. Nowadays, it has become a very basic thing of vibration measurement, whatever be the field. So if you have an accelerometer, you please better have a CV-01. If you're having more than 10 accelerometers, you can consider CV10 or even the CS18 system. And if you're having one microphone, please consider 42 AG. You're having more microphones in the range of 5 to 10. You can 42 AP or AC piston phones. You can also consider to have the CS18 acoustic calibration system from Spectra. We have a calibration laboratory in Chennai. So we have the acoustic vibration calibration system from Spectra. So this is the complete system. So this is the so here is the control unit and then the amplifier. So at the end of calibration, the only effort that you have to make here is to mount, then start by software. So the software will be the calibration process will be completed and you will get a beautiful report like this. So we have the capabilities to also calibrate a microphone. So we can with the Spectra system, you can calibrate CP and charge type, piezo, PR type, and DC MEMS type accelerometers. I would like to mention here one more point. As of now, we are the only lab that calibrating around close to 20 to 21 or 22 levels. So I have myself seen the calibration reports of other laboratories, but I think we are the calibration facility that gives more flexibility and information to the customer. So we have listed the master equipment here, their calibration date, and we also give the complete table and the calibration graph. So each of the report is signed by our managing director. So you get a very good report from us. And we are soon to be NABL accredited. So it is in the process. So leaders for calibration to us. So we have our next webinar on Tuesday, vehicle test system for all applications. We will be focusing on data loggers and data acquisition system from M+P Germany, Link, Microphone, and Soundtech. So please register for the webinar. Please visit our website and register for the webinar. So I'm ending our session.